Welcome back, everyone. And if you've ever found yourself at a philosophy conference thinking that everything you've heard up until this point was well-grounded and very carefully, now it's time for some baseless speculation.
Thanks, Chris, and thanks to the organizers for giving me the opportunity to inflict this wildly inappropriate talk on you. So by way of explanation, last fall, these people wrote me and they said, we're having a workshop in March in South Lake Tahoe. The talk started at 4:00 p.m. And I was like, I'm there. And then only later did I realize I needed to produce something appropriate for a pre-read by a general audience. And this is kind of what I did. And I got stuck there. So it's why I'm talking about it. So I'm really about to give you an amateur metaphysics talk, and I apologize for that, but that's what I'm going to do. I guess I should have learned how to advance this before. Which thing do I push to advance it? Okay. Okay. Some of the formatting's been lost. But here's kind of the question. You're supposed to imagine yourself as a naturalistic metaphysician, somebody who's committed, as Tim Maudlin expresses himself, committed to the proposition that our best physical theories, our fundamental physical theories, should guide our metaphysical commitments, should afford us our picture of what the world really deeply is like. Okay, so you're that character, or if you're not that character, I'll introduce a character who I stipulate to be that character. And the predicament you're in is very aptly described by David Wallace here. Our best physical theories are quantum field theories, and they're avowedly effective. They don't purport to tell you what the world is really like. So what's a naturalistic metaphysician to do? That's sort of the question I'm going to talk about. Well, it seems like they should allow their beliefs to be guided by the standard model particle physics. It's our best physical theory. After all, it says something like there's 17 fundamental particles and 3 fundamental forces, and everything, except gravity, is due to these particles and these forces. Other things are composed of these particles. What happens, happens because of what these particles and these forces do. That sounds pretty fundamental in the metaphysician sense, pretty fundamental in the sense of that from which all else is composed, that due to which all else happens as it happens. So, you know, a typical part of the standard model is there's also non-fundamental particles. I'm going to pick on pions. I'll explain why. They're a pair of elementary particles, a quark and an antiquark, bound by a fundamental strong nuclear force. They themselves are responsible for mediating a non-fundamental force, the residual nuclear force that holds nuclei together. So you're a naturalistic metaphysician. You're going to want to be committed to quarks, gluons, pions. And this way of thinking of the standard model, as I said, stipulating that quarks and gluons are metaphysical simples, casts the standard model as fundamental in something like the metaphysician sense. And I've got a quotation from the metaphysician meant to underscore this. This is Peter van Inwigen in a book called Material Bodies, where he's kind of taking on board in his picture of the world the particles of the standard model as elementary metaphysical simples. So our hero, the person who wants to be a naturalistic metaphysician, they're committed to the standard model. They take it to be a guide to what the world is really metaphysically like. So a couple questions, natural questions. What exactly is our hero committed to? And what's the nature of their commitment? How should we understand their commitment? And you know, the first question, sort of easy. Our hero is committed to, among other things, pions. And let me say a little bit about why pions. Why am I picking on pions? I mean, the real reason will come out later. It was something hilarious I found in a physics textbook, but I've confabulated more reasons. Pions are interesting. It was a felt puzzle, a real poser for physicists in the 20s and 30s. What held the nuclei of atoms together? After all, they're full of protons that should repel each other. What's sticking them together? I've got a quotation you're probably familiar with from Wigner at some sort of celebration of Yukawa from 1977. I'm now quoting Wigner. The disorientation in physics, which existed about 50 years ago, is hard to imagine. We can remember it hardly more than we can remember the time when man's chief purpose was to hunt some animals, when he did not have chairs to sit in, did not have beds. It's hard to remember that. But it's also hard to remember how little we knew about nuclei 50 years ago. And while the great men of Europe were trying to explain what held nuclei together by moving around pre-existing pieces of the picture of the world, Yukawa, a young Japanese physicist, started to think about the problem by way of thinking about what must the force be like that holds the nuclei together, and sort of back engineering from that the particle that mediates it. And so he introduced Yukawa potentials and predicted the existence of the pion. I think that's pretty interesting. Also interesting in the sort of philosophy of language kind of way, Yukawa's like, okay, there's a pion, it mediates the nuclear the force that holds nuclei together. It weighs about 200 times the mass of the electron. And almost immediately I found it in cosmic ray phenomenology. Like, the pion, here it is. And then they decided, no, after all, that's not the pion, that's a mu meson, and it was only about 12 years later they found the real pion. So a lot of sort of interesting history and theoretical developments sort of center around the pion. So that's kind of my excuse for picking on the pion as an exemplar of the kind of thing our hero is committed to. They're committed to pions, but not as fundamental. And if that's the answer to the first question, the second question's kind of hard. They're committed to pions, but not as fundamental. Well, one puzzle that poses is what, besides what's fundamental, is there to pions count? Another kind of question is, what, after all, am I doing when I claim that X's, pions, although not fundamental, exist? These sound like questions for metaphysicians, so let's see how metaphysicians handle similar questions. So what follows is sort of a caricature of some debates in metaphysics, but one that I think is useful for sort of amplifying, articulating the commitments I'm imagining our hero undertaking. Okay, so show some metaphysicians a region S containing n metaphysical simples and ask them, how many other things are there in the region S? How many composites are there? Which are the composites in the region S? People who identify as nihilists say none. The only things that really exist are the simples. At the other extreme are people I'm calling universalists, who will say, well, there's as many other things, as many real composite objects as the set has subsets, no matter how gerrymandered or arbitrary the subsets are. Neither of these positions are intuitively appealing. Most people want to be some kind of moderates. So this is supposed to be a picture where it seems like A and B, they go together, maybe they form an extremely small futon, and C is its own thing. And the kind of intuitive temptation is to say, among the furniture of the universe, in addition to A, B, and C, is the futon AB, but not this gerrymandered composite entity, AC. And that's the kind of thing moderates want to say. But of course, in so saying, they kind of take on an obligation to explain which kinds of subsets get to be genuine composites, which kinds of simples get to compose legitimately as composites, and which sorts of things don't. And sort of, there's a schema you can imagine them whipping out. An nonfundamental composite thing, K, exists whenever there's collections of simples arranged K-wise. But the challenge is to find a non-arbitrary way to distinguish the sorts of things that are qualified to be arranged in such a way they qualify as composites from just gerrymandered arbitrary mishmashes. And if you've ever talked to philosophers, you can imagine it being hard to find a stable stopping point between saying there's no such thing and saying everything qualifies. Okay, well, so with that on board, I want to suggest our hero, and maybe I should say he's my hero so I can give him any attributes I want. They're probably a moderate. I think nihilism is out because I said our hero is committed to pions. Our hero is, after all, trying to make sense of the world described by the standard model. And our hero might feel like it's doing the standard model short shrift to withhold from the level of existence things the standard model makes sense of and explains. Our hero is committed to pions. They're not fundamental. Our hero is committed to things that aren't fundamental. Therefore, our hero is not a nihilist. I don't think our hero is a universalist either. Universalist is committed to a non-fundamental existence, such as pions. But universalist commitment to non-fundamental existence is so indiscriminate that it's neither illuminated nor illuminated. It neither illuminates nor is illuminated by the standard model. But our hero set out to use the standard model to illuminate what their fundamental commitment should be. A universalism seems too indiscriminate to be what our hero orders. Okay, so our hero is probably a moderate. And here's kind of a bonus. Our hero's form of moderation promises it to be a principled sort of moderation. Moderates have this challenge: what distinguishes things that deserve to be composites from things that don't? Well, our hero can say the circumstances under which simples are bound into genuine composite entities are circumstances the standard model describes. There are circumstances where there's gluons. There are circumstances where the simples are bound by the forces of the standard model. There's nothing arbitrary like that. In fact, it's underwritten by a law of nature. Like how much more of a principled distinction between which kinds of aggregates are real composite entities and which kinds are gerrymandered messes could you want? Okay, so that's a little bit about our hero. It may alarm you to learn that in addition to metaphysics, there's something called metaphysics or meta-ontology. It's sort of the field of philosophy that takes on the question of what are we doing when we make existence claims? What are we doing when we make existence claims? So now imagine a bunch of metaphysicians in the room and ask them, what are we doing when we claim that non-fundamental things, say pions, exist? Well, here's some answers they'll come up with. I'm going to imagine a crew I'm going to call Carnapians. And I'm going to revert to this distinction Carnap drew between internal and external questions that I'll quickly sketch in case it's not familiar. Take the existence claim, there's 12 men on a football team. It's 12, there's a 12th football player. Take that existence claim. To ask with respect to that existence claim an internal question to ask, to construe, is there a 12th football player as an internal question, is to pick some sort of framework for adjudicating such questions, like the rules of Canadian football, and see whether according to that framework the answer is yes. So construed as an internal question with respect to the rules of Canadian football, is there a 12th player on the field? The answer is yes. Construed as an internal question with respect to the rules of American football, the answer is no. So these questions have factual answers that are determined by the frameworks with respect to which they're raised. But you might imagine somebody pressing the point. Yeah, but is there really a 12th player? Is there really a 12th player? Well, Carnap says maybe we can classify it as a different sort of question. Not a question raised within a framework that's adjudicated by the rules of the framework, but a question raised concerning frameworks. Is there really a 12th football player? Obviously not, I say. Obviously not. My answer is no. I'm answering the external question, no. Is there really a 12th football player? But Carnap says, what I'm doing by giving that answer is not signaling what sorts of things there are or aren't in the world. What I'm doing is expressing a commitment to confront the world of sport in terms set by the framework of American football, a pragmatic commitment to the framework. So hearing questions of existence as external questions involves hearing them as having answers that aren't right or wrong, having answers that don't register what there is and what there isn't, rather as having answers that are more or less apt given your aims, your context, your self-understanding. So Carnapians want to hear existence claims not as saying anything about what the world is like, but as expressing commitments to navigate the world in terms set by certain frameworks. Okay. That's one view you might have of what we're doing when we make existence claims, just registering pragmatic commitments to the frameworks those existence claims occur in. More sterner, resilient, is a realist attitude towards existence claims. And here, realist is to be distinguished from scientific realism. Here, what realism means is you think existence claims have truth values. They can be true or false, not merely apt or not given your aims, true or false. Existence claims have truth values. So according to realists, when I'm making a claim about whether pions exist, I'm either saying something true or saying something false. where something like that schema pi, a pion exists whenever there's a quark anti-quark pair bound QCD-wise, has a role in determining, given the distribution of simples, whether my existence claim is true or false. Okay, so realists think existence claims have truth values. And this is a sort of system of distinctions you can find in a nice paper by Chalmers. I expect this will sound a little bit like a dog whistle, like hard to hear to a lot of you, but you can also distinguish between existence claims understood as true or false, where the truth or falsity as limned by the schema pi is either simply a meaning stipulation. So I say pions exist, that's true if there's the right kinds of things in the universe, but that's not telling me anything about what's really in the universe. It's just telling me about how I use pion talk. That's a lightweight way of regarding existence claims understood realistically. A more heavyweight way is understanding existence claims construed realistically as, when true, making substantive ontological claims. Like I said, I feel like this is a hard distinction to feel motivated by, but this might help. In that book I cited, Material Beings, Van Invigen argues people and other creatures, wildebeest, people and wildebeest, they really exist. But things like tables and futons are just simples arranged table-wise and futon-wise. If you can hear that contrast, you're hearing the distinction between heavyweight and lightweight realism with respect to existence claims.
I'm supposed to understand that as people in wildebeest exist, but tables don't?
They don't really exist.
Continue.
Is there like an Aristotelian motivation behind that? Like,
Yeah, I feel like he rediscovered Aristotle.
Oh,
Yeah,
he-
yeah. No, it feels very
so natural
Aristotelian.
forms exist,
Right.
but, okay.
Yeah, so if that helps you, that's, yeah. So if we take Aristotle's metaphysics, natural things exist, and like artifacts are just a kind of nice accident, but they're not things. They're not natural. Yeah. No, it helps to have been properly brought up to sort of hear the lightweight, heavyweight. So I'm gonna, because he's my hero, say our hero, his commitment to pions, not merely pragmatic. You're not saying, I'm gonna tell you what the world is really like, and say pions exist, and say, but all that I mean by that is I'm undertaking to confront particle physics phenomena in terms framed by pion talk. I'm also going to suggest our hero's commitment to pions isn't lightweight. Our hero wants pions to be there in the way Van Invigen thinks wildebeest is there. Wildebeest are there, and not in a sort of thin way that tables are there. Okay, I'm going to admit what I'm talking about here are quantum field theory guided commitments to non-fundamental entities, where the non-fundamental in question is understood compositionally in terms of things that are made from more basic things, rather than in other sorts of grounding patterns that are explained by more basic patterns. I think the sort of categorization I just undertook of our hero as a moderate who's neither pragmatist or lightweight carries over to the more general notion of grounding. I want to avoid talking about explanatory grounding, because I feel like the literature on emergence and explanatory grounding is like something like the Palace at Versailles. It's vast, it's Baroque. I think it's easy for the unwitting to give offense if they don't know enough about courtly etiquette. So I'm going to try to keep things simple and talk about compositional grounding, which is, after all, the kind of non-fundamentality suggested by the popular take on the standard model. And yeah, I'm just admitting again that I appreciate that the lightweight, heavyweight distinction might be hard to hear, but I'll try to argue that it's maybe more pivotal than it might initially seem. What's missing here, and this was my fault, is section headings. We just finished a section called Composition Problems. We're starting the section. We just finished the section called Commitment Problems. We're starting the section called Composition Problems. In this section, quantum field theory makes a fleeting appearance. So this schema, a pion exists if a quark anti-quark pair bound QCD-wise exists, casts pions as quark anti-quark pairs. So where in the standard model are these things? Well, here's one place you can find quarks. It's part of the Lagrangian density for QCD. You can see the up and down quark fields there. I'm leaving out the rest. They don't interact. There's some gauge fields there. They're hiding in the first kinetic term and in the covariant derivative. But by a long-standing tradition of sort of reading the quanta of excitation we should be committed to off the fields that appear on a Hamiltonian, this device describes quarks, up quarks, and down quarks. And I think this long-standing tradition of reading our commitments off the Lagrangians deserves scrutiny, but I'm not engaging in the scrutiny here. Let's just take it as a read for now. So there's the quarks and the anti-quarks. One place pions appear is in chiral Lagrangian. You can see pion fields, neutral, positive, and negative. This is a pion decay constant. It's chiral Lagrangian. It's good for describing the internuclear interactions. Whereas the QCD Lagrangians are normalizable. It's asymptotically free. The coupling goes to 0 as energies go to infinity, makes it good for handling really high energy phenomenon. The chiral Lagrangian is not renormalizable. Higher order contributions dominate. They undermine its empirical adequacy at scales above 1200 MeV. But anyway, it's where one place pions are. And now, the thing that I think makes trouble for our hero, who he just told this nice story about how our hero could be committed to pions as nonfundamental, is that the relation between the quark degrees of freedom in the QCD Lagrangian and the pion degrees of freedom in the chiral Lagrangian isn't that well understood. So the pion degrees of freedom and the quark degrees of freedom, they're not defined explicitly in terms of one another. And here you might want to compare something like the Hamiltonian for the BCS model, where you can see the Cooper pairs, how they're defined in terms of electrons, or the, just so I can say Bogoloo bonds, how the Bogoloo bonds are defined in terms of electrons and holes. There's sort of an explicit interdefinition that explains how those kinds of entities are related. No such thing, I think, is available for quarks and pions. Another way you might have a handle on how quark degrees of freedom and pion degrees of freedom are interrelated is, like I said, the chiral Lagrangians, not renormalizable. We have another example of a non-renormalizable but useful theory, the four fermion theory. And the four fermion theory is thought to be a kind of low energy effective theory induced by and derivable from perturbatively the electroweak theory. So the electroweak theory stands as to the four fermion theory as a kind of lucid ultraviolet completion. That gives us a handle on how degrees of freedom in the higher energy theory are related to degrees of freedom in the lower energy theory, some sort of handle. But there's no such relation between the QCD Lagrangian and the chiral Lagrangian, because the coupling is the coupling of the strong force gets stronger as energies get lower. It's not clear how to apply the QCD Lagrangian directly to a low energy phenomena. And maybe there's a story to be told via matching conditions, but matching conditions are pretty empirical, and they're not going to give you much of a handle on how the degrees of the quark degrees of freedom and the pion degrees of freedom interrelate. Okay. So where does the chiral Lagrangian come from, if not arising perturbatively from the QCD Lagrangian? Well, here's a kind of standard story. It's a way to get to pions without the mediation of quarks. I mean, the first thing we need to do is pretend that quark masses are 0, because they're small. They might as well be 0. And if we do, the QCD Lagrangian has a chiral symmetry. You could rotate left-handed quarks into right-handed quarks. But this symmetry, lattice calculations suggest, is broken. The non-zero vacuum expectation value that's not invariant under the symmetry of the dynamics, known as a quark condensate. Tells you the symmetry is broken. And everybody knows that if a continuous symmetry is broken, and the textbook I quoted before, we've gotten as far as the chiral symmetry of QCD is broken. The Schwartz textbook says, at this point, we'll forget all about QCD and just use the symmetry breaking pattern to write down an effective description. And features of that effective description are, everybody knows that when you have a broken continuous symmetry, these massless spinless particles appear in the low energy effective theory. The appearance is mediated by picking a symmetry breaking vacuum and expanding solutions around it in terms of variables artfully chosen so that zero mass field appears. This is the Nambu-Goldstone boson. Of course, there's no spinless massless particles in nature, but that's okay because the chiral symmetry wasn't exact. So the line is pions are pseudo Goldstone bosons associated with the breaking of LQCD's approximate chiral symmetry. And then this is why I really wanted to talk about pions. I thought this was hilarious. The textbook goes on to say, the symmetry breaking pattern alone will tell us a tremendous amount about how pions must interact with each other. Their interactions are independent of whether they are composed of QCD fields or of little green aliens. Okay. And a tremendous amount. You get the pion decay constant, you get pion scattering, it helps you get this formula telling you how quark masses scale with pion masses. It's chiral Lagrangian's pretty empirically rich. Okay, so theories that share QCD's commitment to quarks aren't the only candidate ultraviolet completions of chiral field theory. So the chiral Lagrangian, regarded as effective, isn't on its own going to tell us anything about whether how pions are related to quarks or to little green aliens or to vortex particles. So we know pions aren't fundamental, but it's hard to say we know that what is fundamental under these circumstances. And if we don't know what's fundamental, we don't know how pions are related to what's fundamental. And we can't invoke an articulate relationship between pions and what's fundamental to explicate or underwrite our commitment to pions as non-fundamental entities. So maybe you have good reasons to think pions exist, but we haven't got great reasons to identify them as quark-anti-quark pairs. And we haven't good reasons to invoke the t-shirt version of the standard model to explicate pions that exist as communicating an interesting, substantive, non-fundamental existence claim. That's what I've tried to suggest. So we get an unsurprising moral, this kind of ontology debate between the nihilists, the universalists, the moderates. It's kind of resisted harmonious transposition into the register of particle physics. And this leaves us with an unresolved question. How should our hero understand her commitments to pions? Okay, so let's start over. Let's start over. This section's quasiparticles. The philosophers didn't help us. Maybe some ideas from physics will. What about the quasiparticle idea? So you have a quantum mechanical lattice, it's got protons, it's got neutrons, it's unbelievably many degrees of freedom, but it also has sort of elementary excitations that are quantized and that propagate and interact in tractable ways. These are phonons. And although phonons can be multiply realized in incomprehensibly many ways by the underlying protons, neutrons, and electrons in this lattice, the differences between different realizations don't matter to the how to explain heat transfer in a crystal. The effective physics is the same, and the effective physics is happily communicated by effective descriptions involving phonons. So a phonon is an example of a quasiparticle. And here I've got David Wallace praising quasiparticles as models of the kinds of things that, in terms of whether we should regard them as real or not, are as good as we're going to get. Are quasiparticles real? They can be created and annihilated. They can be scattered off one another. They can be detected. Sometimes we can even measure their time of flight. They play a crucial part in solid-state explanations. We have no more evidence that real particles exist, and indeed no more grip on this than this what makes a particle real. So it seems absurd to deny, says Wallace. So here's a suggestion for our hero. maybe pions are quasiparticles, patterns in a quark-antiquark condensate, or whatever. If what makes them what they are is their patterniness, it doesn't really matter what their pattern's in. And, you know, quickly add, and that's as real as we have any right to expect anything to be. But maybe this is too fast. This is a philosopher talking about quasiparticles. Here's a physicist talking about quasiparticles. You can find lots of people drawing about this distinction. This one comes with the best picture, so I'm using it. Maddock here, he juxtaposes the phonon kind of quasiparticle that Wallace latches onto with the electron quasiparticle. It consists of the original real individual particle plus a cloud of disturbed neighbors. And he contrasts this electron quasiparticle from the other kind of quasiparticle, which he brands fictitious. Okay, so there's a sense that this physicist wants to be drawing an ontological distinction that our hero might want to be aware of. And to unpack the ontological distinction, I want to shift sciences again to the science of ornithology, which I've indicated typographically comprehends ontology. And I want to consider a couple of course in practice criteria of ornithological commitment, ornithological ontological commitment. One is this folk saying, if it walks like a duck, quacks like a duck, and looks like a duck, then it has to be a duck. And here's like a different attitude that I think maps onto Maddox. It's a quotation from an Ann Arbor 4-year-old interviewed by a developmental psychologist. Big bird isn't real, you know. It's only a costume. There's a real bird inside. And now I interrupt this talk to do some history of technology. It's apocryphal, by which I mean it's almost certainly false, but people say it on the internet, it suits my purposes, so I'm going to repeat it, that the walks like a duck, quacks like a duck sort of saying was inspired by the work of this celebrated Frenchman of the 18th century who created really elaborate automata, including the digesting duck. And the digesting duck was a huge hit. The digesting duck, it would walk around, it would peck kernels of corn off the ground, it would defecate. It was Pierre de Vaucanson, he was called, or Jacques de Vaucanson, he was called. In actual fact, his digesting duck, here's a pamphlet, he lays out its principles. It didn't actually digest the kernels of corn. The kernels that pecked off the floor would go into one compartment and there would be sort of prepackaged feces that came out of the other. And the French, being a very precise people, called him to task for this, but he still thought he could make an actual digesting duck. And I mean, like I said, he was fairly celebrated. Apparently Voltaire said, without the voice of Lamar and Vaucanson's duck, we'd have nothing that could remind us of the glory that is France. That's the technological interlude. But the point is, if I use the criterion of commitment, if it walks like a duck, talks like a duck, it's a duck, to say Vaucanson's duck's a duck, I don't think I'm being a very discriminating ornithologist. I think I have pretty lax criteria of ornithological commitment. I don't think I know much about what ducks are. I mean, when I got to graduate school, everybody loved using the phrase exactly not, and I vowed never to. So I'm not going to say Vaucanson's duck is exactly not a duck. It's not exactly not a duck, but it's not really a duck. This idea that if it acts like a particle, it's a particle, well, this is Maddox's point, I'm saying. He wants to distinguish between two sorts of quasi-particles. The ones you'd be committed to if you've got the sort of tepid criterion of commitment. If it walks like it's a duck, it's a duck. That's the second kind. And the first kind that has more of what it takes to be a particle. So two sorts of quasi-particles. The dressed electron, which there's a real bird inside. It's the real original individual particle plus a cloud of neighbors. And then others that are fictitious. They aren't particles, they're just useful devices for describing collective excitations. I think this distinction should matter to our hero. our hero who wants to have commitments to non-fundamental entities that are guided by the standard model, because our hero's commitments are vulnerable to a couple sorts of threats. One sort of threat I call pragmatic appropriation. So an evil pragmatist confronted with our hero saying, pions exist. They can say, yeah, pions exist, but all you should and do mean by that is that it's useful to do physics in terms set by the pion notion. Your claim that pions exist, it doesn't have a truth value. It's not saying what there is and what there isn't. It's saying, it's expressing an undertaking to think of the physical world in terms of pions, a merely pragmatic commitment. Another kind of threat to our hero's commitment is ontological deflation, the thought that, okay, you can say pions exist, but all you're doing when you're saying pions exist is undertaking to use pion to refer to sort of appropriately organized pion realizers, whether the realizers are quarks or gluons or little green aliens or bosonic strings. It's kind of a walks like a duck commitment. And a symptom that this commitment's kind of superficial, kind of lightweight, kind of thin, is that it survives revisionary re-renderings. I think there's a pion there, only it's not really a quark-antiquark pair, it's little green aliens. Still, I think there's a pion there. That's not that robust a commitment to pions, or it's a different sort of commitment to pions than commitment to pions that's, insofar as it's a commitment to pions, is also a commitment to what pions are. So a way for our hero to defend their commitments to pions against pragmatists and lightweights is to say, okay, pions are quasiparticles, but they're the first kind of quasiparticles. They're the quasiparticles whose constitution we understand. And being constituted as they are is part of what makes them what they are. I'm not going to be fooled by Vauquelin-Hassan's duck because I have a more thoroughgoing notion of what it takes to be a duck than the quacks person. But the problem, again, is this mode of defense of our hero's commitments against pragmatists and lightweights. It rests on a lucid account of how pions are realized in underlying ontology. And our hero doesn't have that. Okay, last section is, as you can see, called Ramsifying. So back to Big Bird. Maddox's distinction, which I've used to try to make trouble for our hero, and then suggested our hero can resolve the trouble only by invoking what our hero lacks, an account of how pions are realized in underlying ontology. Maddox's distinction appeals to some antecedent criterion of what it is to be a particle. You compare a mirage. A mirage, it's a relatively stable pattern. Its regularities we could understand in terms of underlying physics, but a mirage isn't really there. It's certainly not really a lake. It's not really a lake because, upon further review, it lacks properties criterial for being a lake. It's not wet. It's not such that if I walk up to it, I can dip my feet in it. Same kind of problem with Maddox's fictitious particles. But now, this is meant to be thought that's some solace to the hero. The appeal to some antecedent sense of what it is to be a particle, to challenge the hero's commitment to pions as quasi-particles, maybe that appeals illicit. Maybe that appeals illicit for the sorts of reasons we've been talking about all conference. The recent history of physics has attenuated our grip on what it is to be a particle. The particles of particle physics, they're not identical, they're not localizable, they don't have mass and sets with determined cardinalities, constitutive features like mass, they're scale dependent. And if the history of physics has been revising our particle concept to the point where I think it does make sense to stop talking about particles and talk about quanta or something instead, maybe the reasonable response is, instead of importing to your discussion of particle physics ontology preconceptions about what particles are, let the theories you're letting guide your metaphysical commitments tell you what their key elements are. Let the theories we're interpreting dictate what it is to be a particle, what it is to be a pion. Which leads to a second moral that's not surprising, but I like it. interpretation of physical theories matters, especially for our hero. So, here's some thoughts about how our hero might let our best theories of physics guide their commitments to pions. And they're thoughts that culminate in kind of my thesis, which I never said. My thesis is going to be something like the ways of understanding commitments to, say, pions most conducive to our hero's aims of undertaking metaphysical commitments, being a moderate, not a pragmatist, not a lightweight. Those ways are also not that plausible. They're the most precarious. But yeah, one idea about how to understand what a pion is to say, here's what a pion is. There's a pion there if there's a quark-antiquark pair bound, as QCD says. Quarks and antiquark pairs are bound into pions. But the catch for our hero with this is if she claims pions exist and nails her flag to the mast of this explication of what pions are, she's probably wrong. There are so many other ways pions might be realized than by QCD, and so many reasons to think QCD isn't the final story, that this account of what pions are, if it's married to pion existence claims, threatens to undermine those existence claims. She winds up with commitments that are false. Okay, so here's another try. And the superscript R there, this section is called Ramsifying. So Ramsey sentences, this is a kind of quaint and not totally germane technology, but I'm going to talk about it a little bit because I think some of its elements can be extracted. So suppose physical theory takes the form of an axiom system presented in a first-order language whose vocabulary cleaves into theoretical vocabulary and observational vocabulary, or vocabulary you already know how to use and vocabulary that by articulating the theory you're trying to figure out how to use. Ramsey showed that there was a way to construct a gadget that was as powerful empirically as the theory was, that seemed not to undertake any theoretical commitments. And the way basically consisted in replacing theoretical vocabulary with bound variables and then existentially quantifying over them. And there's, debate in the history of the philosophy of science about whether this is a way to strip a theory of theoretical commitments, or a way to understand the kind of theoretical commitments a theory undertakes. I don't want to wade into that debate, but just sort of take on board the idea that one thing you can do when somebody comes up to you with a theory is rather than saying, oh, yeah, the things are exactly as the theory says they are, is to say, well, something like this. A pion exists if there's something that plays something like the role in saving particle physics phenomena that quark-antiquark pairs play in QCD. Okay, this sort of seems more robust against falsification by the world failing to cooperate with its expectations about its fundamental constitution. So a suggestion for our hero, say that pions exist and use this kind of quote-unquote super-duper scare quotes ramification of QCD to explicate what you're doing when you're saying pions exist. But I think the catch here, it's a little bit of a bluff. Remember the problem in the first go-round with letting QCD's account of pions as quark-antiquark pairs explicate our unfundamental commitment to pions was that it wasn't really that well spelled out. So it's a sort of bit of a bluff to say we've got a grip on what role quark-antiquark pairs play in accommodating the phenomena pion physics accommodates. And if it is a bit of a bluff, like we don't know when it is commitments framed by this understanding of pion talk should be triggered, it's not even a serviceable guide to merely pragmatic commitments, because we won't know when to undertake them or not. Okay, so here's another try. this time what we're scare quote Ramsifying is the understanding of pions offered by the chiral Lagrangian. A pion exists if and only if something plays something like the role in saving particle physics phenomena that pions play in the chiral Lagrangian. This seems like it's going to have more determinate content. This seems like it's going to be more robust against falsification by the truth about underlying physics. This seems like might do the job of eventuating in defensible existence claims, defensible commitments. But now I think the catch for our hero is existence claims articulated via this way of understanding what pions are really easy to understand pragmatically. It's really easy for a pragmatist to come along and say, oh, all you're doing when you're saying pions exist is saying, I'm going to keep using the chiral Lagrangian to accommodate particle physics phenomena. And I also think it's difficult to articulate truth conditions for pion claims so understood that don't collapse to a description of particle physics phenomena. So this way of understanding pion existence claims, although I think it generates defensible pion existence claims, I think also is prone to being a mere meaning stipulation. And not just a mere meaning stipulation, but kind of an instrumentalist one to boot. It's a very non-committal as far as what the world is really like notion of what it takes to make it true that there's pions. So I think there's some sort of trade-off here. And again, this isn't surprising. The more plausible, defensible, likely to persist, effective as far as actually guiding commitments, our hero's account of what pions are is, the less likely those commitments are to take the form our hero wants them to take, of being like heavy-duty commitments about what the world is really like. The more vulnerable those commitments are to pragmatic appropriation or deflation, until revisionary rereadings, lightweight readings. I'm not expecting anybody to be convinced by all this, but these are a series of considerations that, according to the picture I've sketched of how our hero wants to understand their commitment to pions, that kind of commitment is hard to come by. And that is, brings me to my last slide, which is, well, my penultimate slide, a series of morals. One moral is the kind of debates conducted in the metaphysics literature don't always transpose harmoniously to the setting of physics. That's not so surprising. Also not surprising, interpretation matters. This sort of good, the bad, the ugly type standoff between pragmatists and lightweight realists and heavyweight realists, it replays all over the place. That was part of Chalmers's point, and I think the ontology of particle physics is one of the places it replays, with the attitudes and stances aptest for our hero also being the ones that are least likely to be correct. So our hero is kind of quixotic. And then the one proposal I want to leave you with is sometimes there's a real bird inside. And that's my talk. Thank you.
So I won't keep it cute, but I'm going to actually use my privilege and insert myself first. So I'm curious just about one kind of approach your hero might take. Mm-hmm. So I think the lack of harmony. I've always thought that reading the sort of ontology literature is like you take physics and you have a predictable functor to the hero set.
Yeah.
And you try to formulate questions of composition only using topology if you have. And you just lose much of the quantitative structure that's present in physics. But the question is whether you think there's any way for your hero to formulate a position which isn't, here's a term like pion or a term like quark, but here's a quantitative structure of the physical theory. Can I interpret that as representing real structure in the world and have a kind of heavyweight realism about that without being committed to entities and posing these questions of composition that seems to trouble? So this is the admission early on. I'm
going down the path where we're thinking about commitment in terms of commitment to entities, which is not a promising start to begin with.
Yeah.
And we're understanding commitment to entities compositionally, where the entities we're committed to are non-fundamental in the sense of being built from more fundamental things. I think it's just one way to take physics seriously. I think I need to know more about how exactly, and I think probably the route you're describing is more promising for just the reasons you state, that it's more thoroughly informed about what physics is really like. But I still,
Yeah, there might still be trouble.
yeah, there might be in trouble ahead of the same form. I mean, what it takes to make the trouble is the suggestion that the theories we're using are working as well as they are, not because they're getting things right all the way down, but because whatever theory gets things right all the way down, they're approximating what it says about the regimes we're applying it to. And like, in a way, the question our hero wants to answer affirmatively is the way things really are, well, is our best current theory a reliable guide to the way things really are? Where the way things really are, I treated it as a picture of how things are built, like a toddler's building block picture. You're right, totally naive, ridiculous, but take the way things really are to be a more sophisticated reflection of what physics says about the way things really are. Nevertheless, what our hero needs is an affirmative answer to whether our best current theories are a reliable guide to the way things really are. And I think even if the guide we extract is more nuanced and sophisticated, I think the same sorts of reasons, there's going to be the same sorts of reasons available to pragmatists and lightweights to say, okay, you can express faith by answering that question affirmatively, and I admire you for your faith, but I don't share it. And yeah.
So Eduardo, sorry, I saw a bunch of people, but Eduardo first.
All right, so thank you so much for this talk. You need to think of me as a 4-year-old. Then it's very naive when approaching this. See, because I'm a physicist and I'm metaphysics, I consider it extremely complicated. It's scarily complicated for me. You gave examples, so you relied on your example of the pion, right? Here's something to think about, because in this kind of way of understanding the standard model that I blame particle physics for, which is the t-shirt version of the standard model, right? That even on Wikipedia you get like illustrations with those things as well moving and so on. A pion, to me, if you ask me, I would say no, a pion is not made of two quarks.
Yeah.
It's definitely not made of two quarks. These quarks are entities that exist in the imagination of the people who write free Hamiltonians and don't consider interaction between them. So do you need something to declare fundamental in order to think about this? So can you do the same kind of construction thinking that everything is effective? Everything that we have is just effective? Like, there's no really, say that what I think is right, which if you ask me, I would say yes, obviously, because I'm convinced is right. There's no such thing as quarks that make a pion.
Right.
Pion is definitely not made of two quarks. It's made of, it's way more complicated to describe that. So quarks in themselves are illusions. So they're not fundamental things they're not elements of physical reality, if you want. From your talk, I kind of got the idea that in at least some of the possible constructions, you rely on the existence of something that is fundamental, that is well known, right? Because you say, it's an effective particle, it's a quasiparticle? No, I don't remember. It's an effective particle, whatever you want to call it, of the first kind, of better, because we know where it comes from. But I would cast doubt on that even in the most fundamental model. The standard model is definitely not telling you what these things are made of. It tells you it's very predictive, don't get me wrong. It's as a physicist, I'm satisfied with it because I don't want to assign an ontology maybe, but it predicts its predictive power. But if someone tells me, the pions are better than other effective particles because we know where they come from, I would tell them, well, maybe you do, but I don't think physicists do. You know what I mean?
Yeah.
So, what do you think about that?
No, I'm totally on your side. I think the best we have are effective theories. What I'm trying to point out is it's hard to feel like we do, and then also say I'm a naturalistic metaphysician. I'm letting our best physical theories tell me what the world is fundamentally like, because let's be fair, neither of us believes our physical theories tell us what the world is fundamentally like. Yeah. So the sort of rhetorical structure is, I was imagining somebody who wasn't like either of us, who had been motivated by various eloquent pleas to think we should be interested in physics because it's fundamental, and part of our interest should be it guides our metaphysical commitments, and then trying to make sense. That sounds like a great overarching program, but what concretely do you wind up committed to? And I was trying to make sense of that. And it was in the mode of trying to make sense of a position of somebody who doesn't think effective, or thinks,
So maybe let me recast the question. If we suddenly, if we talk with someone who's a natural metaphysicist, or metaphysician, you call it. Is that the word you use, metaphysician?
Metaphysician, I think,
Not metaphysicist.
Yeah,
Oh.
don't ask me why.
Yeah, I know.
Yeah.
So you get you talk with them, and then you tell them, and is this kind of your hero kind of metaphysician, and tells you, right, but I believe in pions because they, I know where they're from the building blocks of the fundamental structure that they just tell me. Suddenly we inform this person, actually physicists don't think quarks are fundamental. Did we just destroy this hero? Would the destroyer be depressed immediately, or is a way out?
It's kind of an anthropological question. Maybe they would be, or maybe they'd find some physicists who were more confident than you, or they time travel back to when it was easier to do.
But should they? Then they cast into ethics. So should they?
No. I think they should. I think this is the point of the Wallace quotation on the very first slide. He calls it a paradox. Maybe that's overstating a little bit, but I think it's really hard. It's not obvious how to acknowledge that our best physics is merely effective, and then also think it's a guide to metaphysics. And for what it's worth, I think, well, I won't go there, but I think it's a weird place to start with as a metaphysical approach to begin with. But let's set that aside.
Thank you.
And Dave, sorry, what?
Sebastian had a finger.
Oh, so that was a
No, I
finger.
saw that. I had a hand.
Okay, I'll put you on the list. Dave?
Yeah, I mean, so like, I guess two things. Kind of one to that last thing. I feel like the way to probably think about how a thinking person from our hero's perspective would react to the fact that quarks aren't fundamental is just to say, well, not terribly surprising, but something is, and quarks are somewhere up the hierarchy themselves, and so you'll have to have a similar story about what quarks are, right? So like, I agree with you that composition isn't the right way to kind of attack this thing. I think like probably a better way to think about what the sense in which pions exist or whatever is something like the sense in which like the electric field vector exists. I think of like, suppose you have a sophisticated picture of classical electromagnetism according to which it's like integrals around loops that are the fundamental stuff. It's not right to say that the electric field vector is built out of integrals around loops. Instead, what's right to say is that there's some domains in which it doesn't matter, the harmonic Bohm effect isn't happening, and differences between what's going on in my frame and other frames don't matter. And so within that domain, you don't go very far wrong to say that there is an electric field vector, as opposed to, even though it would be more accurate to say that there are these loops. Still, it's not very far wrong to say that there is a vector that does a particular kind of job of charges.
Yeah, I think that is the most promising way to make sense of the magnetic field vectors. But I get uncomfortable with hearing within a domain it's not far wrong to say as expressing what I think naturalistic metaphysicians want as their commitments. It sounds to me way more like an answer to an external question. Is there electromagnetic field vector than as a metaphysical commitment?
Well, I mean, I think that when it comes to non-fundamental ontology, the sorts of characters that you're interested in, like Door and Cider and stuff like that, are a lot more comfortable with the idea of things being, so what somebody like Door would say is, there is a fundamental domain.
Mm-hmm.
There are a lot of non-fundamental domains.
Pure fictions.
Well, yeah, you could say that, right? But like, I think in a more contemporary mode, you would say something like, we can kind of speak different theoretical languages.
Yeah.
And one of those matches the structure of the world perfectly. Others of those match the structure of the world to a lesser degree, depending on what questions you're asking, right?
Yeah.
So I think, in other words, I think they are on board with the idea that there are going to be these sorts of times and places to speak in a particular way about things that aren't part of the basic building blocks, even though it's always correct if you know about it to talk about the basic building blocks.
Right, yeah. But maybe the point I want to insist on is, maybe there's a way of defending as correct in this sense the thought that pions are made of quarks and anti-quarks. But if really they're made of little green aliens, you're taking on a commitment that's the right sort to sort of serve as a metaphysical commitment, but it's a wrong one. It's not just, if no matter how good thinking of quarks, pions in terms of quarks and anti-quarks, no matter how well it serves you in these domains to these degrees of accuracy, it's still wrong. And it's not that we can't understand these commitments in a way that's apt for metaphysics. It's that the understandings that are apt for metaphysics also, in the absence of some real reassurance that we're on the right route to the final theory, are probably wrong. So quark physics is more fundamental than pion physics, but is it in fact an interpolating step between the true complete underlying theory and pion physics? I think it's sort of an open question whose answer might be no.
Wayne? So your hero wants to be a naturalist position, wants to know what's fundamental, but wants to get it from physics.
Mm-hmm.
Has to confront the fact that there has never ever been a candidate for a comprehensive fundamental physical theory.
Yeah.
The standard model is great, but it's formulated on flat space-time and doesn't include gravity. So I think that the best thing for your hero to do is just shut up until this is come up with that. But suppose I don't.
Do you want to tell him that?
I think I have. But there's still a problem. Suppose we acknowledge that we don't have fundamental physics. What we have is something that works very well in a certain domain. We can still ask the question: what is this physics telling us about the world? What does it tell us about the world that this theory works well? And I think that strikes me as you're still doing metaphysics.
Okay.
So I guess I want to hear, so is there, how much, if you get rid of this idea that somehow you're getting at the fundamental, how much is left for stuff in enterprise that could be called ontology, could be called metaphysics, or asking what is this physics telling us about the world?
Yeah. I think there's definitely scope. So the question, what is it telling us about the world that this theory works as well as it does? There's a line about what it is to interpret a theory, where the line is, what it is to interpret a theory is to say what the world must be like in order for the theory to be true. The question you're asking is a different sort of question. It's like, you're not demanding that the world make the theory true.
Right.
You're demanding an account of the world whereby it makes sense that the theory succeeds as well as it does. Totally legitimate question, important question. I think it's a question with respect to quantum mechanics the Bohm theory undertakes to answer. And it's instructive that the Bohm, just stipulating quantum mechanics as it appears in textbooks is a full-fledged theory in its own right. The Bohm theory says this statistical theory, this statistical prescription works as well as it does because, in fact, the world is a swarm of particles following the guidance equation. It's an answer to the question you're posing about quantum mechanics, and it's an answer that, if it's right, does seem like a good guide to metaphysics. It's also, and this is like important to me with respect to these sorts of questions, an answer that like pins down what the underlying physics is. There's a way to answer the question you're posing, which I agree is a central question, and a question I think philosophy of physics is being improved by pursuing more and more, where the answer to the question, what is it about the world that makes it such that this theory works as well as it does, that the world's just such that this theory works as well as it does. This is an effective theory. I don't know why exactly it works as well as it does, but I'm reassured that it's going to continue to work. And that seems like a really good answer as well, but not such a good guide to metaphysics, because it's not taking on not offering a concrete account of what lies beneath so much as a reassurance that no matter what lies beneath, it's such that this theory will work as well as it does. So yeah, that's the question you raised is a central one. There's ways of answering it that are lucid guides to metaphysics, possibly, if they're right, and ways of answering it that I think are good answers that don't really tell you much determinate about metaphysics.
Ben?
Yeah, can you go back to the mirage?
Oh, yes.
Yeah, okay. So there were two things that confused me
Okay.
on this slide, I guess at the bottom. So one was let the theories dictate to us.
Yeah, no, that's the wrong word. Absolutely, yeah.
And then I also didn't understand how it followed. So like you say interpretation matters. Like that sounds great, but I didn't understand how it related to the other things that were going on.
Yeah. Yeah, so like rather, the thought is our hero can defend against Maddox-style assaults, which I'm presenting as having the form that you say this thing's a quasi-particle. That's not what a particle is. By going on the offensive and saying, I'm going to let my theory guide my notion of what a particle is, rather than importing a notion from the antecedent conceptual gear I bring to the world. And here the idea, I think it's a good one, is that part of what theories do is they expand the repertoire of concepts we use to confront the world. And just because there's homonymity between a concept a theory uses, it's called a particle, and a concept already used doesn't mean it's the same concept. And then I think it's appropriate in that circumstance for the philosopher, the physicist, to let the theory offer some guidance about what the conceptual expansion consists in. Dictating is absolutely the wrong word, because I think there's a lot of free choice involved. There's many, many options, and it's important. I think other people have emphasized this here. It's important for the present and future of physics to explore the possibility space. But the point is, the possibility space is not exhausted by previous uses, even if they have maybe previous uses of a word that's homonymous with a word that does heavy conceptual lifting. Did that answer all your questions? Oh, and then the interpretation of the exercise of exploring the possibilities.
You're on this question.
On this very point, the difference between what you wrote there and what you just said is the difference between, think of Stein thinking of what you want a theory to do is to be a good clue for getting a more fundamental theory. And the way you just said it in words would fit that.
Right.
Whereas this doesn't.
Yeah, no. I think that's not, the word Ben latched onto was misleading. I was trying to fit a thought on a slide. But I stand by what I said, especially if you like it better than on the slide.
Porter and then Sebastian.
Okay, so and then possibly rethinking this question. Go ahead and roll or someone else.
Okay, Sebastian's next.
Okay. Thanks. I think my question is related to one of the questions before. It makes sense, I guess. So I think if you're a naive, naturalized metaphysician, you get into a lot of trouble all the
Yeah.
time, right?
That's another moral.
Yeah.
Yeah.
So if you're like that, then you will have to. Well, I mean, physicists seem to talk about all these objects that once you try to interpret them, well, it's not that easy, and sometimes you should be careful about whether you commit to everything they seem to talk about or not. Energy and general relativities, we are still debating how to understand it, and things like that, right?
Yeah, yeah.
So I'm trying to see the dialectic here with pions. Pions, we say, well, they appear in QFT, in the standard model, and the standard model seems to be a very good theory. So here you go, you have to be committed to them, and you have to give me an answer to what they are or something like that. But maybe a more sophisticated naturalized metaphysician would say, well, not everything you find in a theory that seems to be very good or fundamental, you have to be committed to everything they talk about.
Yeah.
And I don't know if that would be a way of resisting the good argument you're giving here. Or here is another, maybe more radical way. So pions are fundamental, but they are primitive. Like, you cannot explain them in terms of quarks. So take that as face value. Yeah, they are pions, and they are not even like quarks, as physicists seem to say. I don't know, maybe I would like to know what you think about these two routes. Be more sophisticated in the sense not commit to everything, or take as face value that they are not given by quarks, and so take them as entities or something like that.
And so I think the first route sort of coalesces some of the things Ben and Chris were talking about. Just I'm rolling drunks here. There's probably a more sophisticated way to extract metaphysics from our best current physics. But I think what I said to Chris, I'm going to kind of stand by. As long as there's legitimate room to say, no, our best current physics, no matter how sophisticated our understanding of it, isn't an accurate guide to what the world's really like, then the project of naturalistic metaphysics seems a little bit naive still. But then there's another maneuver you proposed, which is why are we so bound to thinking pions aren't fundamental? Why isn't the way to go just to take the apparatus of our effective theories and say that's fundamental? And what we've learned is that's kind of the best we can do as far as making sense of what's fundamental. I've been asked this question before, and I don't really know what to say to it. It seems like a pretty dramatic alteration in the usage of fundamental. Like, for instance, it creates the circumstance where pions are fundamental, but in 40 years we can find out that we convince ourselves of some account of what they are that marshals things other than pions, which is usually taken as a signature of not being fundamental. If something else explains you, you're probably not fundamental.
You would say, well, we thought they were fundamental.
And when we were wrong.
But right now, since we cannot view them out of the fundamental, maybe.
Quick thing, because I didn't want what I said to be read as in like pions have to be fundamental. No, I do believe that pions emerge out of QCD and the fundamental the fields of the standard model, like the quark fields, the fermion fields, the fermion currents. Pions are collective excitation of some kind. What I'm saying is not made of two quarks. It's not two building blocks. The mass of the quarks is of the order of megaelectron volts. The pions is 100 electron volts, so it's more to it. The gluons are mass 0 if you want. It's more to it. It's a collective excitation of those fields if you want. So it doesn't imply. I don't believe quarks are made of. Pions are made of two quarks. Doesn't imply I believe pions have to be fundamental. Then I do believe that they emerge from, even if I don't know exactly how to derive it, I do believe that they emerge as a collective excitation of other fields, and just as they're not fundamental. Whether the quark fields are fundamentals or not, that's a different story. But it's not a dichotomy. That's what I mean. You can still say it's not made of two quarks, but still, definitely I would say it's not fundamental. Sorry.
Okay, Noel, and then Fortune.
So I'm trying to remember how we got into the state of aphoria at the end. There's a worry here. So the hero wants two things, right? They want a kind of mid to heavyweight realism plus.
And they want to be right. That's the
third
second
thing.
point.
That's sort of the third
Okay.
thing. Let's go with sort of higher up some bold conjectures about the world.
Okay.
Right? They want mid to heavyweight realism plus a kind of moderate view about emergent entities.
About composite. And,
I was
and
trying to be a little more
nonfundamental.
general than
Yeah.
composite.
Yeah.
Moderation about emergent entities, right? And so I sort of worry that by the end we got confused because we were trying to sort of solve both things in one fell swoop.
Mm-hmm.
Because when you wrote, your Ramsey chiral Lagrangian story, I remember thinking, that looks like a pretty good, if not exactly right, pretty good functionalist story about what it would be for a pion to exist.
Mm-hmm.
There's a further question about whether or not it's fundamental. So it seems like you could give a kind of Ramsey story about the realism,
Mm-hmm.
and then seek some maybe better story about fundamentality and emergence that would allow us to talk about pions as being non-fundamental.
Mm-hmm.
And this, I guess I'm really confused about this. You pushed aside this as being too easy to understand pragmatically, but that seems to depend a lot on the content of the Ramsey sentence, right? For any Ramsey sentence, you're going to either drift towards triviality or like instrumentalism, depending upon what you Ramsify over. And as long as the Ramsey sentence has some rich theoretical vocabulary, there's a kind of nice, happy, kind of realist medium that the hero could adopt, it seems.
Yeah, I mean, it could be the, because this whole Ramsey apparatus is sort of made up, and the question is maybe connected to Wayne's, the extent to which the sort of understanding we're offering of pions takes on articulate, lucid commitments about what it is that's enabling pions to do the work they do. To the extent,
what the underliers are?
Yeah.
Okay,
Yeah.
that's actually a mistake. But
What's that?
that strikes me as a mistake.
Uh-huh.
I mean, I think once we get into the spirit, there's a lot of emergent entities. Then you got to get some sort of story about what it is for an emergent entity to exist.
Yeah.
And then it seems like an additional question whether or not
Right.
that thing is emergent or fundamental. And
Yeah.
presumably it's the same sort of thing. You want the same structural story. There's just a further question about whether or not it's emergent or fundamental.
Yeah. Yeah. And this just could be like parts of my brain are missing. I don't understand talk about emergent entities. I don't seem to understand talk about emergent entities as readily as other people do. I think.
Well, then there's substitute composition. Because composition is one sort of story about emergence.
Yeah, and I understand composition, but I don't see what the story about composition.
No, I agree with you that the story about what, the fundamentality talk about pions in particular is not very well understood. It needs to be made better sense of it. It seems like we at least have a decent grip on the existence part. And it looks something like that.
Yeah.
When you actually write the
Yeah, they're emergent. We don't know what they're emergent from, but that's enough to give us a grip on the existence part.
You might want an additional story, which is that the functional story you've told is somehow insensitive to the underlying details. That seems to be a potentially important kind of.
No, I think it is, and first of all, that makes it kind of late to me. I feel like being indifferent to construing pions in such a way it doesn't matter what they're. Yeah, sorry, that's yeah.
I was
Okay.
just gonna, so how with emergent entities,
Yeah.
does it matter to you, the answer to the question whether tables really exist as emergent entities or whether they're really only particles?
No, it doesn't. But I know from prior experience that at some point, when I give a talk like this, I'm going to be accused of not understanding what tables are and have no way to defend myself against not understanding what tables are. But in answer to Noel's question, I still want to say the kind of commitments you're describing, you can't stop me from construing them pragmatically. Maybe that's the.
Or I was going to go basically through this acquisition chain that
Yeah.
ours went through.
Yeah.
Okay, well, let's continue the discussion over.
Oh.
And thank Laura.